What's up, everybody? Welcome back to Mathletes Corner. In this video, we're going to be taking a look at the 2025 Aime Ii Problem 3. So let's get right into it. In the problem, we have this 2x2 grid with 12 unit line segments. And we need to color each of these unit line segments either red or blue so that each of the 4 unit squares has 2 red sides and 2 blue sides. And we need to find the number of ways that we can do that. So it's a seemingly simple problem, but it's not going to be simple to solve unless we have an organized and coordinated casework approach. So our first observation is that these 8 outer edges, so 2 for each side of the grid, only borders 1 square. But the 4 inside edges each border 2 square. So from this observation, our idea is to do casework on how many of the inner edges are red. Now, the question is taking up a lot of space, so let's shrink that down. And now we can begin our casework. So let's say we have 4 red edges on the inside. In that case, every square would be bordered by 2 red edges, and we could color all of the outer edges in blue. So there's only one way to do that. Now, if we have 3 red edges, well, there's 4 ways to choose which 3 of the inner edges are going to be red and which one will be blue. Now, let's draw our grid for a bit more clarity. So we just have the inner edges here, and we know that these edges have to be blue, so the top squares are both satisfied. Now, for the bottom squares, we have 2 remaining edges each, and we can choose one of them to be red and one of them to be blue for each of those squares. So in addition to the 4 different rotations, there's also 4 ways to choose the color of the remaining edges. And of course, 4 times 4, that's just 16. Our next case is when we have 2 red edges. Now here we need to be careful because there's actually 2 subcases. If the 2 red edges are opposite of each other, or if they're adjacent of each other. If they're opposite of each other, the blue edges will also be opposite, and if they're adjacent, then the blue edges will also be adjacent. Now, in this first subcase, where the red edges are opposite, each of the 4 squares has a choice. So one of the 2 outer edges for each of those squares has to be red, and the other one has to be blue. So for this, there's 2 to the 4th, which is 16 ways. For the next subcase, we know that these 2 edges have to be blue, these 2 edges have to be red. And now we only have to make the choice for this square and this square, so that is 4 ways. Now, of course, for both of these cases, we need to count the rotations. So for the first subcase, we can either have this edge and this edge, or we can have the other pair of opposite edges. So we have 16 times 2, which is 32 here. Now here we can take these 4 inner edges and we can rotate them in 4 different ways. So we get 4 times 4, which is 16. So we've already done a lot of work and we're starting to get tired of this question. So we can notice that if we have 1 red edge, then there must be 3 blue edges. So this case is just symmetrical to if we had 3 red edges. Similarly, if we have 0 red edges and 4 blue edges, that's symmetrical to having 4 red edges and 0 blue edges. So we can just copy the results from the first 2 cases. So we get 1 plus 16 from the first 2 cases, Then we can multiply that by 2 for the symmetry. And then we can add our results from this final case here, where we got 32 and 16. So we can add 32 and 16 here. This comes out to 34 plus 32 plus 16, and that adds up to 82. That's all for this video. Thank you for watching. Don't forget to smash that like and subscribe button, and we'll see you next time here at Mathlete's Corner.